Hello. So we have two figures, two geometry figures, and it's a surface area problem. So we're given that, of course, this is a hemisphere and that's a cylinder, and that their total surface areas are equal to each other. Now for these problems, this base right here doesn't count, right? We don't adjust for that. We are only looking on the outside part. So knowing that, the formula for the cylinder part of it is going to be pi times r times h times 2 up front. I should have put that out there first. So what this is doing, this right here, you should be familiar with. Oh, I keep on clicking the Windows button. This right here is the circumference, right? It's the circumference of the circle, and then you multiply it by h to get this whole, the whole lateral surface area of it. So that right there is the lateral surface area. Uh, and then you add just the bottom base, which everyone should be really familiar with how to get that. It's just simply r squared times pi, right? I better rewrite that too to make sure that you know it's an exponent. Okay, just like that. And we're going to set that equal to the hemisphere. Now, since we're not accounting for the base, the hemisphere will just be literally half, the hemisphere's surface area, sorry, will be half the surface area of a regular sphere. And since a regular sphere is 4 pi r squared, this is going to be 2 pi r squared. Now we can simplify this. First of all, you should notice that these two are like terms, right? So we subtract r squared from both sides, or r squared times pi from both sides. You're going to end up with just 2 pi, and I'm going to cancel that out. You're going to end up with 2 pi times r times h is equal to pi times r squared, just like that. Okay, now we're having to isolate for h. So you just divide by 2 pi on both sides, 2 pi r, and even in here, you could cancel out some things, right? So you can cancel out the pi's, and you could cancel out that r by just removing one from the exponent. So your answer is just the radius divided by 2. And you get the 307.